Hey everybody, welcome to Mistake Man. I'm starting a new project and I am really excited about this. I don't know if you can tell from the pieces that are laid out in front of us here, but I'm going to be building a model of the warp core from Star Trek The Next Generation, from the Enterprise D. This is Geordi LaForge's pride and joy. I had this idea, I don't know, 5-6 months ago, something like that. And what I want to do is actually light this and animate the lighting so that the coils at the top will light up in blue and then pulse downward just like they do in the show. And it's going to just kind of be freestanding on the table, and it'll have a couple of coils at the bottom like this. There will be a base, and there's going to be a couple of coils, and then the reaction chamber will go like that, and then there will be 2 more coils up on top, and then out the side of the reaction chamber will be the power transfer or plasma transfer conduits out the sides like that, and they'll glow red. Anyway, I'm really excited. I think this is going to be really fun, and I think it's going to look really cool if I can pull it off. Like I said, I had this idea several months ago, and about, 2 weeks ago, I decided, you know what, I'm going to do this. I'm going to create this thing. So I sat down to my computer, to my design software, my 3D modeling software, and I was getting ready to start modeling this model. I needed some reference pictures of the actual engineering set from the TV show. So I went to the internet and just started Googling the TNG warp core and started looking at all the pictures that were coming up. And as I was flipping through those pictures, I saw a couple that actually looked like someone had built a model, pretty much like what I want to do here. I followed the breadcrumbs of those pictures, and they led me to the 3D printing model download site called Thingiverse. You've probably heard of it. And there was a creator on there named CrazyJ. And this creator had actually designed a model of the warp core intended to be 3D printed and lit just like I wanted to do. And so it was perfect. Somebody had already actually done all the work and had posted that model for free, available to anyone to download. And so I did. I downloaded it and started looking through the models, and I got instantly excited because all that design work was already done. I did not have to do it. So I immediately started looking at these models and figuring out how to 3D print them. Now, one thing that I've done differently than the original designer, they designed theirs to be printed with a filament printer, the FDM process. And I do have a filament printer, but I've never been able to get really high quality prints out of those. They're always pretty rough with really distinct layer lines and not... Anyway, I'm not that good at printing with that, and so I didn't think I would like the output for a display model. So I decided to instead see if I could just print this with my resin printer, which I can get better models from. But that did necessitate me actually kind of looking at some of the models and the way they were designed to see if they could just be printed as is, or if I would need to make some modifications to the models to make them more suitable for resin printing, or at least more suitable for me to resin print, because I'm still pretty new to this whole 3D printing thing. So as I was going through that, most of the models that he created were actually just fine. I could just print them as is with resin and without really making any modifications. And so I did that. Like these are the support pieces that go in between the coil segments like that. And I didn't need to make any modifications to this at all. I just plated it up and supported it and printed it out, and it turned out great. Same with these outer lattice shells for the PTC conduits, and there's some caps that go along with those, the end caps, and then there's the clear piece that goes inside that, like that. And the original designer has modeled it with some interesting structure on the inside. I'm not really sure what the purpose of that is. Maybe just to kind of pipe the light and give it kind of an interesting look from the outside. But also like a slot to put a strip of LEDs underneath. And then that cap goes on the outside like that. And then this goes in there and then attaches onto the chamber like that. And then there's the same situation on the other side. So there's there and there. So I didn't have to make any modifications to these. They just printed out as is. And these little pieces are just the back piece of the support that goes on like that. Because this has to be a separate piece, because otherwise you wouldn't be able to get the coils in place like that. So the original designer has done a lot of great work in creating a great model and also considering all the assembly steps, things like that I just showed you. They thought about all that stuff, and it's really well put together, well designed model. These coils are also, I didn't have to make any modifications to these. I didn't have to. I didn't turn out well. I'll show you that later, but I did make some changes to it. I decided not to go with those changes, and just ended up printing these as they were from the original design, and they look great. There are a few parts of this model that I have not yet printed. I've got another coil. There's a top piece that goes on the top set of coils. The very top of the model caps it off. And I've actually got that on the printer right now. It's printing as I record this. And then there's the base. There's pieces down in the base, and I have not printed any of those yet. There are some lit parts of the reaction chamber. So these two halves of the reaction chamber don't go together like that. There's actually a space between them. And then there's bars that go around the perimeter. And then that gap between there is lit with a white light. And then there's also this dilithium chamber hatch that goes on the front here, like that. And those two half circles there are also lit with a white light. And the original designer provided models for those light diffusers all the way around the reaction chamber and behind this feature here to diffuse the light. This is one of them here. So I printed that out of the clear resin, and that goes behind here like that. Fits in there. And then I guess I'd have to like paint that white or really sand it to diffuse that light coming through there. Still got the pattern from my build plate. I just printed it directly on the build plate. So, and there's a bubble in there. Didn't get bubbles on any of my other parts, but on this one I did. But I don't know that I'm going to use this. I think I might just cut out a piece of sheet styrene that's already white and quite diffuse and put that back here. And the same thing for around the reaction chamber for the white light that goes around. The original designer of this model did provide models there's 3 pieces of like that you'd print out of this clear stuff, the clear resin, and it's the same idea as this to diffuse the light. I decided not to print those because, again, I think I can just probably put in some sheet styrene between those, and I think I'll like the look of that better, and it was easier, and I didn't have to bother with 3D printing anything. So this reaction chamber I did modify quite a bit from the original model. The original model was all one piece with the bars that go between and with these PTC conduit thingies sticking out the side, and also this dilithium chamber hatch. That was the whole reaction chamber. That was all one solid one-piece model, and it was intended to all be printed like that. And apparently the designer did do that. They showed their pictures of, you know, their finished model, and again, they printed it with filament, with FDM, and it looked good. And they apparently printed it all as one. But when it came time to start, you know, supporting this on my build plate for printing it with resin, I couldn't find a good way to orient the model and that wouldn't produce weird results and that would not just be a pain to support. And so I made the decision to go ahead and remodel this piece so that I could break it up into multiple parts to print. So I did remodel this, and I did follow the original design mostly, like the actual shape, the contour and the shape, because the original designer did some great research and created a great model that looks almost exactly like the screen, the on-screen warp core. So I didn't have to do a lot of extra work to go in and do all that research to figure everything out. I could just follow what the original designer had done and then just modify it to suit my needs. And I figured out a way to break it up into multiple pieces. As you can see, I split it into two halves. I found that easier for me to support and print. And the little bars that go between, I took those out of the 3D model because that is one thing that I did change about the design. The original designer had some more robust, thicker bars going around, and it looked like there were fewer of them on their model compared to the on-screen version of the reaction chamber. So I did decide to slim down those bars a little bit and add more of them so that it was more in line with what it looks on screen. And in doing that, I wasn't confident that if I had printed those, they're about, 8 millimeters in length. Well, you can see if I put this in here, this spaces that out, what it's supposed to be, like that. So, and you can kind of see the diameter. I put some little recessed holes in there to help me put those bars in. So they're not very big. I think they're like a 1.5 millimeters in diameter. So I just wasn't sure that they would print, I think, okay, but they'd be very fragile and very prone to breaking. So I decided to actually just take those out and replace them instead, and create them instead with some rod stock styrene. So that's why I added those recessed holes around the rim to help me put in some of that stock styrene. And as you can see, it goes all the way around. And since I was breaking this in half, I decided to make the dilithium chamber hatch be its own piece that could be placed on, and I made a little recess for it to fit in. And then I did the same thing with these PTC conduit exits with again just a recess that goes around, and so it'll go like that. So I broke these out as separate pieces as well. The original design also had some features at the top. There's a triangle shape up here, and then some like raised rectangles, right? One there and then one on the other side here. And those are for some labels that are on the reaction chamber. I decided to do some custom decals for those, and so I just didn't put those features in my version of the model. Okay, let's talk about the lighting. The original designer used LED strips, kind of like this, not exactly this, but this is what I have just to kind of demonstrate. But It's RGB lights that are individually addressable. These ones are not individually addressable, but the version that the designer used were, and there were more of them per strip. And the idea was to run those along here on the inside so that there was an LED. You run the strip vertically so that there's an LED at each position of the coil, and then you run multiple strips around, and then use something like an Arduino or like an ATmega, I think is what was called for in the original design, to program those lights to light up in sequence down the coils, and then on the bottom to go up the coils so that they meet in the middle with the reaction chamber. And then, each row of lights this way would light up one at a time. So it would light, and then the ones behind would go off as it goes down. And that gives us the pulsing effect with the blue lights. And it looks really cool. But you can kind of see the individual LEDs behind through the clear coil parts. You can see the individual spots for the LEDs. There's the hot spots for where those are. And in the TV show, there's like the light is in bands. It almost looks like I don't know how they built the original warp core, but it almost looks like maybe there's like a ring of probably neon lighting, like neon light tubing that goes around, and it looks like there's 2 bands per coil, and they light up as they go down. And it looks so cool. I want to see if I can replicate that look. And so I think I'm not going to do the LEDs like this. Instead, what I'm going to do is some of this COB strip lighting, like that. It lights up more smoothly. You can still see individual little dots, but I think it's going to end up looking more to my liking. And I don't really like the normal blue. Normal blue LED lighting is like a very vivid, kind of a dark blue, which I don't think is the right color for like Starfleet warp technology, like warp nacelles, and for the warp core and the Enterprise D. And so I found this COB strip lighting that is actually like they call it ice blue. So let me plug this in so you can see what that looks like. This ice blue looks more of a cyan blue, like a lighter blue color to my eyes. Camera really blows it out. It's hard to tell the color, but maybe I've got this is like your ordinary blue LED that I've put in my little tester here. And it's a much darker, more vivid blue, right? If you're familiar with blue LEDs, you know what I'm talking about. That blue LED color that almost messes with your eyes, but this is more of a, I guess to the greener side of things, but it's, like I said, more cyan. And so this looks perfect for the warp core. And so the color's great, and you don't get the hot spotting behind the coils. So I think that's going to end up looking pretty cool. But since I decided to do a different strategy for the lighting than the original design, I had to modify this part, because this part was designed specifically for the original lighting scheme. Instead of strips going this way, like in the original scheme, I need my strips to go this way so that they can light up. And I'll put a strip in each one of these spots and just light it up to create that pulsing effect. This COB strip lighting gives me a nice even blue light all the way around. But I want to see if I can replicate the effect that I see in the show, where there's those 2 bands of neon tubing that actually light up. So it looks like there's light coming just from like a narrow strip, or 2 narrow strips along each coil. So one thought that I had to try and do that was to modify this model and actually put in like 2 grooves on the inside that would kind of replicate like those bands, and then somehow mask off the inside everywhere else except for those bands, so light can only go through in those bands. So I tried that. I modified the model with those bands and printed it out, and then I got this. You can kind of see there's the 2 bands in there that light can go through, and then just to mask it to light block the rest of it besides those bands, I just decided to put some paint in there. So I masked off the bands so I didn't get paint on them. I was using masking fluid, this stuff here, this micro mask, liquid masking medium, to basically paint inside those bands, let it dry, and then spray paint it on the inside. But as you can see, it didn't leave the cleanest lines. And that, unfortunately, you can see from the outside. I tried to figure out a different way to mask that off that gives me a cleaner line. And one thought that I have is to use some of this aluminum foil tape, because it's really thin and it 100% blocks any light trying to go through it. The trick is, though, how do I mask each one of those individual rings? How do I lay tape in there that's in any way straight and better than the result I've already got here? I thought about it for a while, and what I came up with is to actually put it on some clear, just a clear plastic sheet. I can take a piece of tape, of the aluminum foil tape. Actually, it takes 2, because unfortunately the tape is not quite wide enough to go across the whole thing. So I have to lay a piece down, then get another piece next to it. And then I can mark the spacing that I need and use a straight edge to just cut only through the top layer of tape, but not through the layer of plastic behind, which is not that difficult to do. As you can see, I've done it here. And this results in some nice clean lines. It's got some wrinkles in it, but that's just because I've been bending it around. Once it's bent around to kind of fit inside there, it tends to smooth out most of those wrinkles, and you can't really see them from the outside. So then the idea is to roll that up, and this just has an angle on the side just because it's a scrap that I had to test this idea out. I'll plug in the light here. We can take a look at see how that looks. And I do kind of like the way it looks from the outside. You can kind of see from the outside, it kind of gives it a cool shiny look. Just that aluminum foil tape. I don't know, I just like that. It's kind of cool sci-fi look. Oh, there you go. If I pull the light back a little bit, the camera does pick that up a little better. Okay, I've got one here that's finished. And you can see they've got did that same technique, and this one wraps all the way around. And I forgot to mention, for this technique, I don't need those extra bands that are printed on the inside of the 3D part, the 3D model. So I don't need to print them like this. So I went back to just printing the rest of these coils with the original model part, and not my modified versions. I've been working on the electronics to control the pulsing light effect. I think I've got something that's going to work. So let me show you that. Put some power to this. So what I've got here is this chip on the left here is a 555 timer chip, and it's putting out just a steady beat, as indicated by this little white light here that's flashing every time that pulses. And so I've got myself just a little oscillator circuit set up here, and the output from that timer chip is then being fed over to this chip, which is a CD4017, and that's a decade counter. and every time it receives the signal from the timer chip, it ticks over to a different output, and then that output is driving these LEDs here. So every time this light pulses, this one of these switches over to the next output. And I've only got 5 here. In the full model, I will have it driving 10. So it'll go, because there's 10 coils, 2 sets of 5 on the top, and then 2 sets of 5 on the bottom. And then the two, I'm going to have them synchronize, the top and the bottom. So it'll count like 1, 2, 3, 4, 5, 6, all the way to 10. 10 is the last one before it gets to the reaction chamber. And then it'll, once 10 goes out, it'll start back at 1 and pulse down. And so I didn't want to set up all 10 here. I just wanted to make sure I got the timing and the counter circuit working correctly. And so I just am testing that with 5. So when it gets to the end, I've got it just looping back to the first one. Okay, this chip here, the one on the right, is a ULN 2803, and it is an array of transistors. Basically, it's a Darlington array with this. I think this one has 7 channels, maybe 8. I think it's 8. This is an 8-channel Darlington array, and that's not necessarily needed for this particular setup I have here, because I could drive these LEDs straight from the counter chip, and it would handle just the small amount of current, the 10 milliamps or whatever I'm running through here for each of those LEDs. That'd be fine. But for the strip LEDs, for these guys, each 4-inch strip of this LED is going to require about 100 to 120 milliamps, and I can't run that through the Decade counter chip. So I've got to instead use that to switch a transistor that then powers the LED directly from my 5-volt positive rail. And rather than having, like 20 discrete, or I guess it would be 10 discrete transistors, I decided to use one of these arrays. And where each transistor in this array is a Darlington pair, it can handle up to, I think, 500 milliamps per output. So that's going to be great. Because I actually, where I'm going to be synchronizing them so that the top and the bottom ones are on at the same time, and then it moves to the next one, the next one, and then the next one, I'm going to be using the same counter pulse to turn on both of these at the same time on the top and the bottom, and I'm going to run both of those through the same transistor. So I need 200 to 240 milliamps that are going to be going through that. So, but this should work fine for that. So I got all that set up to make sure it would work, and as you can see, it's working just fine. I guess I'm going to need 2 transistor arrays because this is only 8 channels, and I'm going to need 10, so I'll have to have another one. Okay, so I've got this set up just pulsing one at a time. I want to see if I can set this up so that when the next one comes on, the previous one doesn't go off completely, but it's still on, but at a reduced brightness, so passing a reduced current. And then, once it moves to the next one, then this one gets dimmer, and then this one gets even dimmer or goes off. I want to see if I can kind of make a trailing effect as it goes through. I think I've got an idea how that might work, so I'm going to give that a try, and we'll see how it goes. Okay, I've made my modification to the circuit, and all it really was is adding in some diodes between each of these LEDs. Okay, here's my circuit diagram, and so I've got the counter chip here driving these transistors, and when this transistor is on, then current can flow through and this LED turns on. Even though there's a connection to these other LEDs, they can't turn on because current can't flow through the diode backwards, and current won't flow through the diode this direction because all the rest of these transistors are off. So it's just the first one's on. Then when the counter cycles to the next, then this transistor turns off, this transistor turns on, and the current can flow through here. But now current can flow through this LED, but not through this transistor. Now it has to actually go through this diode and through to 0 volt through there, and etc. as they kind of cycles through then the current from the ones behind. So let me show you what that looks like. So this is the result, as you can see. So that's the leading one. That's kind of the brightest one in the pulse as it goes through. And the ones behind it get steadily dimmer as it goes. And that's because for each successive LED that goes over, these other LEDs have to travel through one diode and then 2 diodes and then 3 diodes. And each time it does that, there's a drop off in voltage. There's a voltage drop across each of those diodes. And so, so the LEDs just end up being less bright each time they go. I think the trail off effect is going to be more dramatic, like it's going to trail off steeper when I'm driving these, because these require quite a bit more current to drive them. But that's the idea, and I think it might work. It's kind of cool looking. Okay, I've got some of these ice blue COB strips wired up. I'm going to hook these up to my my pulsing circuit, and we'll see what that looks like. Okay, got these all hooked up. Now let's turn on the power and see what we got. That looks so cool. Oh, I love it. Oh, that looks so much better than I thought it was going to look. Oh, that's so cool. I kind of want to see if I can get this inside the coils, just to see how it looks for now. I'm going to see if I can do that. Okay, so let's turn this on. Oh, that looks amazing. That looks so cool. I just had to see how this was going to look with the full 10, so I went ahead and set that all up. So let's plug it in. That looks so cool. So this this set of coils up here has the aluminum foil masking inside of it, light blocking, and this one doesn't, so you can kind of see the difference there. I think this is a little slow now that I'm seeing the full 10 coils pulsing through. So I'm going to adjust the frequency that this timer chip is clocking, and I'll just do that by swapping out this capacitor. I think I'm going to look at double the frequency, see how that looks. And so the way I'm going to do that is just change the value of this capacitor. It's cut the value of the capacitor in half. So it's 10. This one that's in here is a 10 microfarad. I've got a 4.7, which is about half. So I'm going to swap that out. Okay, now let's try that. Yeah, I think that should be good. So if you think about the sound you hear whenever there's a scene in engineering, you hear that thumping sound from the warp core, and it's like boom, boom, boom. It kind of makes that thump every time the pulse reaches the reaction chamber. Yeah, that's pretty good. I like that. I finished printing the top piece that goes on this model, and it fits on the top of the coils like that. This piece is not the same as what's in the original design of this model. I did end up redoing this, basically creating a new model for this. The reason I did that is when it came time to plate up and support the original model, I realized that the whole thing was solid inside. Now that wouldn't be really an issue for the original intent of the model, which is to print with FDM, because you could just do infill there and that would take care of itself and be just fine. But for the resin printing, it is possible to do infill on resin parts, but I have no experience with that. Never done it, not sure I would do it right. So that got me thinking I need to make some modifications to this part or just remodel it. As you can see, this version is quite a bit different from the original, so I did end up actually just recreating this from scratch. When I was doing research for this model, one of the references that I used was this, the TNG Technical Manual. This is a book that I got back in the 90s, and as a kid I absolutely loved this book. Just all the great technical illustrations and just so much detailed information about how the Enterprise works. Completely fell in love with it. It's even got a section on the warp core and how that concept looks. And when I was flipping through here, I saw this illustration of the warp core assembly, and this top piece up here, the matter reactant injector. I decided I wanted to model it to look like it does in this illustration in the book. Obviously we never see this assembly in the show at all, so there's no like reference photos of a set build or anything. So this is what I have to go by, and I think it's a cool design. So I decided to model it to look like this illustration. And as you can see, I got the shape from that and the proportions, and I even added the panel lining on there to match what was on the model. I did take a little bit of artistic license with this part here, just to add in kind of this fin detail, because I did want to kind of thin that out so it wasn't as thick as it would have been there, and I just thought the kind of the fin detail would look kind of cool. So I did that, and then also for the top, I did like this feature on the original design of this model. It had this feature on the top, and I think that looks really cool, so I brought that over from the original. Just kind of replicated that design on top.
I've taken the circuit that I had laid out on my breadboard and transferred it over to an actual prototype circuit board here. Laid everything out and got it all soldered up. I hope you'll forgive the croakiness of my voice right now. I've been feeling ill for a couple of days. But anyway, I wanted to show you this. So, just kind of give you a brief overview of my layout here. So this is the 555 timer chip and the resistors and capacitors that are associated with that. And then I've also got just an extra little LED here with its resistor to pulse out the clock timing, just for diagnostic and debugging purposes. And from the timer chip, the clock signal goes over to the CD4017 decade counter, and all of its outputs go over to the two ULN 2003 chips here, and their outputs go over to the LEDs. And here's my little array of diodes, just connecting each LED to the next, and then this wire just connects the last diode to the first diode. And then I've got a header of pins here. There are 22, so there's 20 pins for the top set of 10 LEDs. So that's like the top half of the warp core assembly, and then 10 pins down here for the other 10 on the lower half, and 2 common positives that are shared across all the LEDs. and then input for power. So here's the header for all those 10 LEDs. And here's the common positive. That goes on the first 2 pins. And then we'll hook up our power connector. And then we'll get some power on this thing. But there we go. You can see the little clock pulsing LED there. I just made it really dim because I don't really want its light coming out through the base. I finally printed the base. I ended up remodeling this base. I wanted to use the original part, but it was quite a bit thicker. Almost the wall thickness was almost 3 times as thick as what I have here. Just again, it was designed for FDM printing, but for resin printing that was just going to be too much. So I did end up remodeling this. I did end up following the overall design of the original, but I made some changes. First of all, I just took off the enterprise registry that used to say NCC 1701D right here, and then it had a clear piece in it so you could backlight the lettering. And I just decided to not do that, so I just made that just the wall continue all the way across. I do like the little communicator badge switch, so I did print that out. It's going to go in there like that. It's going to mount onto latching switch. I don't have that yet. That's being shipped to me right now. I also removed the power jack from the back. There was a hole back here for a DC power jack, but I'm going to be doing something similar to what I did on my USS Defiant, where I'm just going to be powering that with a USB, a female USB plug like this. And so I'll have a little notch for that female connection to come out, and then it can just tuck it underneath when I'm not using it. And then I changed the bottom plate. I'm not going to be printing that. There is a file to print that base, but I'm just going to cut that out of sheet styrene. And again, there were some mounting holes for screws to hold the base on, but I'm going to be using magnets, so I adjusted that to make room for some of these little neodymium. Well, anyway, these guys to go in there, and then I'll have probably just like a flat washer or something on the plastic piece that'll grab onto that, so I can just remove the base easily if needed. So I've got my lighting assembled, and like I said, I've got this band of LED lighting to light up the inside of the reaction chamber. So I'm going to hook that up right now just so we can take a look at that. I'm not going to hook everything up just because it's kind of a pain to deal with, but I'm going to hook up the lighting right here in the middle in the reaction chamber. So I've got the red COB strip lighting for the plasma power transfer conduits out the side of the core. And in order to get that fading white to red color, I decided to just go with a little small section of the white COB and the rest of it being red, which that's actually really hard to see on camera. So let me turn that off for a minute. There we go. So as you can see, the lengths that were available to cut these pieces in worked out just perfectly to put one section of the white and 2 sections of the red, and then it's the right length to fit inside here. It's a little short, as you can see, but this end inserts quite a ways into there,
and so it's pretty much perfect. You can see there. So let me get that on. Here we go. Super overexposed on the camera. It is not nearly that bright in person. Let me see if I can get the camera to adjust a little bit. There. Oh, that's not bad. So there we go. The transition from white to red is a bit stark, but once it's inside the lattice, it looks just fine. I don't want to put it in there yet. I've still got to paint this, and I've kind of got all the masking all set up for how I want to paint this. I don't want to undo all that just to demonstrate this, so I'll show it after this all has been painted. And once I've got the reaction chamber assembled, the next step is going to be doing some painting. Paint all these pieces. They're all basically the same color, just that dark color of the warp core frame. And I've got a couple of paints for that color. I've got this ceramic coat charcoal. It's really dark gray. I'm almost worried it might be a little too dark. And so I did take a look at some other paints while I was at the hobby store, and I did go with, I did like this color here, this AK dark gray. So I decided to give this one a try. So in order to compare these two, I took one of the scrap pieces that I ended up having to reprint, and I put some samples of each of those paints on different parts of the model. So on the right here we've got the ceramic coat charcoal, and that's a flat finish. And then on the left here we've got the AK dark gray, and that's kind of a semi-gloss finish. And now that I've got them together next to each other, they're pretty similar. Other than just the luster of the finish, they look pretty similar color wise. It almost looks like the AK has like a slight greenish tint. It really shows up well on the bottom of the bottle, but it's a lot more subtle once it's painted on the model. But I think I almost like that better. I kind of like that almost weird. It's almost like a weird metallic greenish. Not metallic in the sense that it's like sparkly like metallic paints, but like, I don't know, like a treated metal might have some kind of a tinge of green to it or something. So I think I might go with the AK on this. I'm going to end up painting a matte coat, clear coat over all this when it's done. So I think before I make my final decision on the color, I'll go ahead and hit this with the clear coat and see how they look once they've got basically the same luster. See which color I like. Okay, this is my test piece. I put a bit of black paint on there just because I'm going to be doing some black decals around the reaction chamber. There's some like dark detail lines that go around kind of the midsection of the reaction chamber. They're pretty hard to see because they're black on a dark background, but in certain scenes, in certain lighting, you can see them. So I wanted to see what black paint would look like. I think it's pretty good. I mean, it's subtle, but that's really what I'm looking for. So, in some lights you can hardly even see it. It's a little more visible in person. It's kind of hard to catch it just right on camera, but... And for the AK dark gray color, I do like the way that looks, but when I sprayed the clear coat on it, I used this Duplicolor matte clear coat. When I sprayed it on, it reacted with this AK paint and like bleached portions of it. Let's see if you can see. Yeah, so like right there, those little streaks. Yeah, it had a weird reaction. I didn't really expect it to do that. You can kind of see it on this side as well. You can also see some of it there as well. yeah, I'm going to have to do something a little bit different than that. So that original plan of doing the AK dark gray with just the clear coat on it, that's not going to work. I don't want to risk it doing that again. And I decided I don't really like the charcoal. I mean, it's a great color. I like the color, but it's not really what I'm looking for on this. It's just a little too on the blue side, where this is more neutral, but almost like a little on the greenish side. So I do like it, but I had to start thinking about other things I might do. And one of the things that I wanted to maybe do was to kind of give it almost like a metallic sheen. Not really like a sparkly sheen, but just, I don't know, if I can make it look like it's reflecting in sort of a metallic manner, but still be dark, almost black, really dark gray. So I tried to come up with a few different ways of doing that. I've got this Tamiya color gunmetal, which is like a really dark gray, but that's almost a little too sparkly. But I did try it out, and that's what you can see here. It needed a few more coats. You can kind of see it's a little patchy there, but it got far enough that I realized it wasn't really the look I was going for. It just looked a little bit too bright and sparkly. So another option I thought of is I have this Testors Model Master Graphite Metallic, which is like a really dark metallic color. Similar, but it's just darker than the Tamiya gunmetal. So I tried that out, and I like the way it looks. This is what you can see down on the bottom. It still just looks mostly just like a really dark gray, but then it's got a bit of a metallic sheen to it without being too sparkly. And then once I put the matte clear coat over the top of it, this stuff actually goes on pretty glossy. But when I put the matte coat, it definitely tones that down. And so I think I like that result. It is pretty thin. I have to do quite a few coats to get this to go on this darkly. So I think what I'm going to do is do a base coat of the dark gray, the AK dark gray, and then just with my airbrush mist over a layer of this stuff, and just so I can get that metallic sheen, and I don't have to put on coats and coats of this stuff to get the color, the darkness of the gray color that I'm looking for, but it'll give me that metallic sheen. So I'm going to do the whole thing with the AK dark gray, and then go over with just like a thin coat of the graphite metallic, and that's going to give me the look I'm going for, I think. Alright, I've got my pieces painted, and I like the color. I think it looks good. I'm pleased with this result. I did a fit check on everything, and everything's going together nicely. And then I have the reaction chamber partially assembled. I epoxied in the PTC conduit sleeves here, and then the front of the dilithium hatch. And then I glued in all of these little bars that go around. They're glued into this half. And I just used the top half here to hold those in place, in the right spot and straight while they were gluing on the bottom. But I didn't glue the top on yet because I still need to put in the sheets of styrene for the light diffusers that go around the rim and in the front. Cut those here and here. So I modeled up some decals and got them printed on some custom decal paper. And here's what I've got. And these warning labels do have some white in them. And I'm just using an ordinary like home office inkjet printer, which can't print white ink. So those are actually just the absence of ink there. When I pull those decals off of the paper, they're just going to be transparent everywhere that white is. So in order to get those to show up white on the model, I need to paint some white there before I put the decals on. I made some masks to help me print those little shapes at the correct scale. And this is just printed on copy paper. I'll probably use these to trace out those shapes with some masking tape and try to get those in just the right spot on here. I used these part patterns to create some masks. Like I said, just kind of cut them out of masking tape here. And painted the parts where the decals are going to go. Right there and there, there. Top and bottom there, and then on those parts of the latches, there and there. So now it's time to put these decals on. Okay, here we go. The decals are done. I'm really happy with the results. These decals worked out great. I've never done custom decals with this kind of decal paper before, so this process was new and I wasn't sure how well it was going to work, but this is the decal paper that I ended up using. It's just Hayes Paper Company clear water slide decal paper for inkjet, and these happen to be A4. And I just followed the instructions on the back. And for the clear coat, which is what you do for step 2, you have to seal it after you print it. I went to the manufacturer's website and they have some recommended brands of clear coat spray. And I just went with their top recommendation, which is this Rust-Oleum Gloss Clear 2X, whatever. This stuff here. And it worked great. I didn't have any issues with it, with the ink flaking or peeling or fading or anything like that. I didn't have any issues with the clear coat cracking or anything as I was trying to apply the decals and bend them around these curves. The paper itself was easy to work with. I didn't have any decals that broke. So yeah, I'm really pleased with how the decals turned out on this. We'll get the matte clear coat on there just to kind of tie everything together, and I think it's going to look good. So, okay, as you can see, the model is almost completely fully assembled. All that's remaining is to put the electronics inside. I just need to feed the wires down and go through the top opening in the back. Okay, got that through. And then before I put the top on, I'm going to hook up the circuit board. I've got an extra connector here that I'm not using. I put it on there in case I decided to do the lit up base with the NCC 1701D registry on here, but I decided not to do that. So, okay, and then here's my little USB connector. Just kind of coil that up a little bit under there. Pop the base plate on. There we go. Top goes back on. So this guy is ready to plug in. Okay, here's the final piece of the puzzle. I've got the little COM badge switch painted and ready to go. And yeah, let's just get it put in place. Let's get the power hooked up. Shut off the shop lights so we can actually see what we're doing here. And here we go. Let's shut that light off as well. And there it is. The reaction chamber lighting turned out really great. I was worried it would be too dim, but no, I think it's really good. It's definitely much dimmer compared to everything else that's going on, but it looks just right. There we go. I've got the whole thing in shot now. I put the black backdrop cloth there just so remove all the clutter of my workbench behind it, and you can just see the glory of the warp core. So anyway, yeah, this has actually been a really fun project. It's been challenging for me because I've actually learned a lot about 3D printing of resin parts for this project. I was pretty new to it. The first parts I'd ever resin printed were for my USS Voyager, and definitely had some learning pains doing that. But I was able to learn a lot more about just get better at doing supports and getting more familiar with my machine, using a couple different kinds of resin, the gray and the clear. I've got some other projects in mind that I want to do that are going to involve some resin printing, so yeah, I'm glad I've been able to kind of get into this a little bit more and feel a little bit more confident about being able to try some new and challenging things. I learned some new things about electronics as well. Learning how to use a decade counter and a Darlington transistor array, and do a little bit of diode steering in order to get the trailing pulse effect. And I'm just really happy with the way this turned out. So that'll be it for this project. Thanks everyone for watching, and we'll see you next time.